Yes, it is. Okay, so 4.2, once again, this should be in the on the back of that second page of your packet, so it's really the fourth page you flip through, saying 1, 2, 3, 4. Out of the 6 pages, it's the fourth one. And if you turn your attention to the sideboard where I'm at, if you look under Wednesday, my dudes, on the 28th of this fine month of November, in geometry, which is this class, SWBA. What's SWBA stand for? Students will be able to, you guys as students will be able to, by the end of the period, use isosceles and equilateral triangles to find angle and side measures, which says it's 4.2. That's because it's our section 4.2. So we're going to be talking about isosceles and equilateral triangles a little more in depth today, and we're going to be using them to find different angle measures. So we've already kind of briefly discussed a few of these things, which is kind of convenient for us. So our first thing I'd say is recapping what an isosceles triangle is, okay? An isosceles triangle is a triangle with at least 2 congruent sides. That's what it says here, has 2 congruent sides, and we have these little dash marks there to show us, hey, these sides are the 2 that are congruent. Now, we call 2 of those sides legs. Which sides did we call legs? The congruent sides, okay? And we can see here we have points, so we can call the legs by segments. You guys recall we named segments by 2 points that were the end of the line segments. So A and C would form a line segment. And that would be one of the legs. A and C, segment AC is this side. It's this leg. The left congruent leg. Okay, what would be the other leg? Can somebody raise your hand and tell me? Kennedy. CB. Segment CB would be the other leg. Very good. Now, could you have called it segment CA and segment BC? Yes, you can. You can reverse the order of segments. So either way would have been okay. Now we have a vertex angle. We'll call the vertex angle the angle that's between the 2 legs. That's between those 2 congruent sides. So of these 3 angles, angle A, angle B, and angle C, which of those 3 is between these 2 sides? Angle C. It's where these 2 legs meet. So angle C is what we call our vertex angle. It's the one between the 2 congruent legs. It's the only one between the 2 congruent legs. There's only going to be one vertex angle, yes. In an isosceles triangle, there will only be one vertex angle. So once again, this is for isosceles triangles. So not only do we have legs, we also have the base. The base is going to be the third side of the triangle that's not congruent to the other 2. So which of these sides would be the base? Can somebody raise your hand and tell me which side would be the base? Gracie.
AB.
Yes, segment AB would be the base. Very good. Now we have base angles, and those are going to be the 2 angles that touch the base. So the 2 angles that are touching the base. Can somebody tell me what those 2 angles would be, Nick?
Angles A and B.
Angles A and angle B. Very good. Angles A and B would be the 2 base angles. They're the 2 that touch the base. Now we have this base angles theorem, and we already kind of talked about this briefly. We're saying if these 2 legs are congruent, if those 2 sides are congruent in an isosceles triangle, so go ahead and draw that in, if those 2 sides are congruent, then we will know that the base angles are congruent. And we already talked about that. We said in our isosceles triangle that those 2 angles opposite the congruent sides are congruent. So we're just giving it a name now, and we're calling it base angles. Because the 2 angles that touch this base. If these 2 sides are congruent, the ones touching the base, the angles touching the base, are congruent. Because they're opposite those congruent sides. They are not touching a congruent side. Converse. What's converse mean in geometry? What's that mean for us, Nick? Switches it around. So it takes the front, puts it at the back. Takes the back, puts it at the front. So we're saying if these 2 legs are congruent, then the base angles are congruent. So what do we think the F then is going to be then? If it's the converse. Kennedy, what are you thinking?
The dashes would be at the bottom.
Okay, the dashes would be, you mean the second one?
Yeah.
Okay, so like here, are you just saying yes because I said that?
Yep.
Okay, so,
But now I know what you mean. Because,
okay.
Yeah, now
So what would be the F?
that one.
This one?
Yeah.
Okay, very good.
Because, yeah.
Okay, thanks for being honest about that. I appreciate it. So the converse would flip this around. So we keep the word if and then where they are, but we switch the hypothesis and conclusion, our P and Q, from chapter 2 even. So we're continuing to go back to that a little bit. So we're saying if those legs are congruent, then the base angles are congruent. So now we're saying the converse, flip the order, if the base angles are congruent, then these two sides are congruent. So we can use that to figure out when triangles are isosceles triangles based on measures now as well. Questions on that? Okay, we're going to take a journey right below this to this. It says extra example 2. It's not really an extra example 2. It just came from a book where it was an extra example 2. So we're trying to find the measures of angle X and angle Z. Okay, so we're trying to find X and Z. So we're trying to figure out what this is and what this is, where I just put 2 question marks. And we know this is what kind of a triangle?
Equal.
It's an isosceles triangle. How do you know that? There's 2 congruent sides. Those are marked. So if it's an isosceles triangle, what do we know about these 2 base angles, X and Z? They're going to be congruent, meaning they have the same measure. So we have this thing saying one base angle, so either X or Z, one of the base angles, is going to be equal to 180 minus our vertex angle over 2. Okay, so we're going to say angle X, that's a base angle. Measure angle X is going to be equal to 180 minus, well, what's our vertex angle in this triangle, Faith? The 50 degrees. Our angle Y is between these 2 congruent sides, between the legs of this isosceles triangle. So 50 degrees is going to be the measure of our vertex angle. We're going to divide that by 2. So just like we do with any fraction, we're going to simplify the numerator before we continue. So what's 180 minus 50? 130. Very good. And what's 130 divided by 2? 65. So measure of angle X is 65 degrees. So we found one of them. How can we find the measure of angle Z now? It's the same. How do we know they're the same, Alicia? Because in an isosceles triangle, the base angles are congruent. Okay. So this theorem or this formula we had here is really just something we could have figured out on our own anyway. Sorry, I'll give one more second to kind of digest this information before I continue.
Wait, how'd you get the 2?
So we just use this equation here, but we'll talk about how we actually get there. Yes, Kennedy?
What would happen if this triangle was a right angle, but it still had the half circles and the dashes in?
Right, so if there was a right angle somewhere,
Like-
it would have to look something like this. Is that kind of what you're describing?
On our homework, there was one, and it was I had like the square on top, and I was really confused.
Was it like this but flipped around?
Sure,
Do you want to see if you can find it real quick?
sure.
Okay, that'd be amazing. So, what do all 3 angles of a triangle add up to, class? 180. Okay, if we take away 50, we know we're going to figure out what these 2 add up to, right? Okay, if all 3 add up to 180, we take away this, and we figure out what these 2 add up to. So these 2 are going to add up to 130. And if they're the same, how could we figure out what each of them are? Divide by 2, cut it in half. And so that's how we get this formula. It's really just doing these steps. It's saying, take all the angles out to 180, which is where we get the 180. Subtract away this angle, so we find the sum of the other 2. Subtract the vertex angle. And then divide by 2 to split it in half. Which is actually just all that we did. Okay? You found that, Kennedy?
Yeah,
Awesome.
but the triangle stretched out. So
Oh, okay. So let me see this from here real quick. So the example Kennedy is talking about looks like this. That's one of my better ones, yeah. Thank you. Until that box. Yeah, no, I'll fit there.
Sideways.
Okay. So that's gonna look like 450. That's gonna confuse people. So this is the one that Kennedy's talking about. So she's saying it's a right angle. It's a right triangle because it has this right angle at the top. This is one from her homework that she had a question about. So this is an extra thing. It's not in the notes. We're just talking about this because Kennedy had a question. So we have a right triangle, and we know it's isosceles. Well, how do we know it's isosceles? Two congruent sides, 4.8 and 4.8 are the same. Those are congruent. And then what do we know about these two angles here? They're congruent, okay? And if we look at this, this is kind of like this triangle, but flipped around a little bit, shaped a little bit differently. Let's apply some of the same principles to it. So, in an isosceles triangle, which this is, we know the base angles are congruent. Well, the base is the side that's not congruent to either of the other two. That's its bottom. The bottom's the base in this case. The two angles touching the base are the base angles, and they are congruent. So that holds true. And if this one's 90, then we took 180 minus 90, and we get 90. So these two add up to 90, making them both 45. Does that make more sense, Kennedy? Are you saying that, or does it actually make more sense?
Yeah.
Okay, awesome. Any questions on this example as a whole, though, this first example we did? Okay, we're going to go to the one right below this thing, where it says find the lengths of the sides.
Oh my god.
Okay? Find the lengths of these sides. So let's start this one out. Okay, let's take a second. Let's kind of look at this. Let's just ponder over what we might be able to do. So look at your own sheet and ponder over what you might be able to do, okay? So I want you to take a second and do that, please. No, but I want you to keep thinking about it. Kylie, what are you thinking? Okay? Alright, so let's talk through what Kylie said first, and then we'll talk through what Abby said. So Kylie said, could we add all three of these together and equal 360? So what three things added together to equal 360 on Monday that we talked about? Does anybody remember? Exterior angles. Are these angles? Darn it, so that won't work, okay? So that was a good idea. We threw it out there. Doesn't quite work, so let's move on to something else. Abby, you were saying something. What were you saying?
That two of the angles have to be the same.
Okay, two of the angles are the same. We know that. So what's that tell us if two angles are the same?
Parallel.
Two sides are the same as well. Two sides are congruent as well. That's the converse of the base angle theorem. Right above this, we have that base angle theorem,
Yeah.
you know, right here. Okay, and we have the converse saying if the base angles are congruent, then the two legs are congruent. So which legs would be congruent? A, B, and CB. These two legs would be congruent. They're the legs opposite the base angles. Okay, they form this vertex angle as well. Angle A is opposite this side, it doesn't touch this side, and angle C is opposite this side, it does not touch this side. So they're opposite those sides. Yes, ma'am. Okay, what do you think we should do?
Could we do 6x minus 4 equals 4x plus 4?
Why would we be able to do that?
Because they're congruent.
They're congruent, so we can set them equal to each other. I agree. Okay, if we need to find the length of the sides, we need to figure out what x is, so we can plug it in. For figuring out x, we need an equation. So we need some sort of a lead. And our lead here is saying if these two are congruent, that means they have equal measure, meaning we can set them equal. So we do exactly that. We set them equal to each other. Okay? So how would we go about solving this? Randall, what would be your first step?
To equal, okay, you would simplify.
Okay, how would we simplify?
Add 4. Both sides.
Okay?
And then minus 4x.
So first of all, we get 6x is equal to 4x
Yes, sir.
plus,
8
very good. Okay, then you're saying what?
minus 4x.
I agree, get all the x's together as well. Get all the numbers on one side, the constants on one side, and get the variables on the other. So we get what is equal to 8?
2.
2x. Can't forget that x, okay? And how do we finish off here?
That's 6.
How do we finish off here? If 2 is being multiplied with x, we need to divide by 2. And so, Randall, redemption shot, 8 divided by 2 is
4.
4. Very good. Okay, was our goal to find x though? Darn, that was part of our greater plan, to find x. So now what are we gonna do with this x? Okay, plug it into, where are you saying, Kennedy?
2x minus 3.
Okay, 2x minus 3, we need to find this side so we can plug it in here.
But don't you just... Yes. Never mind, don't listen to me. You're right.
What's 2 times 4? 8 minus 3 is? So this length is 5. Okay, do we still have to find other lengths?
Yes.
Yeah, okay. So do we have to plug it into both of these?
No.
Why not?
Only one, because they're same.
They're the same, so you can just figure out one, right? Okay, so which one do you want to do? This top or the bottom? Bottom. Why do you guys say the bottom? Smaller numbers, and you add instead of subtract. We usually prefer that. So 4 times 4, which is our x, plus 4. It's a lot of 4s. 4 times 4 is 16 plus 4 is 20. So this side up here, AB, is 20. Now, if we plugged it into both of these and we got something different for each one, what would that tell us?
You got that wrong.
We did something wrong, we had to go back and check. But it wouldn't work out here.
He's picking.
Abby?
I thought they had to equal 360.
So that's exterior angles have to equal 360. So all 3 exterior angles have to be equal to 360. But these are not angles. Okay? Questions on this one?
Will this be an acute angle?
Yeah, it looks like all 3 would be acute. Okay. Okay. So an equilateral triangle is a triangle with 3
Angles. 3 dashes. Equal sides.
3 congruent sides. 3 congruent sides. Thank you, Alicia. An equal angular triangle is a triangle with 3 congruent
Angles.
angles. Okay, that's a bit of a review. Bit of a review from Monday. So if we have an equilateral or an equal angular triangle, how would we find the measure of each angle? They'd all be the same because they're all equal. So how does that help us if they're all the same? It does help us, but how? So if we have this triangle, we have an equilateral triangle, we know they're all the same measure. What do all these angles add up to?
360.
They add up to
180.
180. And if there are 3 of the same,
60.
we could divide by 3, just like we divided by 2 and 2 angles were the same. We'll divide by 3 because we'll split it into 3 equal parts. And each one ends up being 60 degrees. So we divide by 3. Yes, it was. Yep. This is the math behind it. So we're going to have the equilateral triangle theorem, which is right here saying if a triangle is equilateral, then it is equiangular. We talked about that yesterday, right? We're saying if all 3 sides are congruent, then all 3 angles will be congruent. Or Monday, not yesterday. And then we have the converse. We said the converse is where we reverse the order. So instead of saying if it's equilateral, then it's equiangular. If it's equiangular, flip it around. This one was last, it's first. This one was first, it's last. If it's equiangular, then it's equilateral.
Just like
So all 3 sides are congruent. All 3 angles are congruent. If all 3 angles are congruent, all 3 sides are congruent. Vice versa, it goes both ways. Questions on that? Okay, so we're going to use some properties of this, and we're going to do an example over it. So Katie is stitching the center inlay onto a banner that she created to represent her new tutorial service. So she's making a banner, she's stitching a center inlay onto it, and it's for her new tutorial service. So it's an equilateral triangle with the following dimensions in centimeters. And we need to figure out the length of each side of the triangle. So equilateral, what's that tell us? Yeah, Gracie?
Never mind. All sides are congruent.
Okay. So Alicia's saying if it's equilateral, then all 3 sides sides are congruent and all three angles are congruent. Well, it says it's equilateral, and we have right above this that if it's equilateral, then it's automatically equiangular. So we can go from there to there. Yes, Faith? And why are you able to do that, Faith? Can you explain that? They're congruent, okay? If they're congruent, that means they have equal measure. So if they have equal measure, we can set them equal to each other. So if they're congruent, we can set them equal. The angles are 60. But we need to find the length of each side of the triangle, though. So we're not looking for angles. We're looking for sides, though. Does that make sense, Abby? William, what are you thinking?
If they're if the angles or the measurements of the sides are equal, couldn't you just do like 6x minus 5 times 3 or something like that?
Yeah, but you don't know what this first side is anyway, so you couldn't. So if I tell you go 6x minus 5 yards far, would you know how far to go? No, you would need an actual number, right? So we could find out what all these would be in terms of x by doing that, but we wouldn't know the actual number. So we wouldn't know a real measurement. Does that make sense?
Yeah.
Okay, that's a good thought process. You have a question on what he was saying
No, problem.
on this problem?
Yep.
What's your question?
I'll just wait till we get started with the equation.
Okay, so we're at our equation right now. 6x minus 5 is equal to 4x plus 7. Would now be an appropriate time, or would it be a little bit later on?
Would you add the instead of subtract the 5?
Okay, you're saying would we add the 5? Yes, we would, because it's subtracting right now, so we do the opposite. Because Kennedy, what's negative 5 plus 5? If you owe me $5,
Yeah.
then you'd have like negative $5, right? If you owe me money, you have negative 5. What?
I don't have any.
Okay, but if you owe me 5, then the first $5 you get should go to me, right? So it's almost like you have a negative amount. Because you start off below 0.
You're in debt.
So then you get $5. So how many are you at now?
5.
Okay, but then you have to pay me.
You're
So you're at 0. So what's negative 5 plus 5?
0.
0. Goes back to 0. So we have 6x is equal to 4x plus 12. So Kennedy, that's why you add 5 when it's subtracting. So that's exactly right. We would add 5. What did you say, Greasy? What was your question?
Nothing. How is it like that? I just combined all my things like at once, so I'm like
Okay. So Gracie, what would you do from here?
-4.
Minus 4x. Okay. And what's 6x minus 4x?
2x.
2x. Very good. Thank you for catching that x. We have 2x is equal to 12. Max, what would you do?
Divide them.
Divide by.
Divide by 2.
Very good. And x
On
is equal
both
to. On both sides. And x is equal to 6. Very good. Okay. So was our mission find x? Was that what our end goal was?
Never is.
No, it's hard. It never is. Sometimes it is, but not often. Okay. So, Brody, what would we do now? Since we found x, we need to find the length of each side of the triangle. How would we do it? Okay. No guesses at all.
I got him.
Okay. Well, let's wait a second. Okay. So let's see what we can get here. Okay. So we know this side is 6x minus 5, and we know this is 4x plus 7, and we know an x. Is there anything we can do when we have an x in there and we know the x?
Yes.
Okay, what can we do?
I don't know.
Okay, you just know it's something. Okay, we can substitute it, which means we put it in place of it. We were doing it on our warm-up. We were doing it on the last problem as well. So, Kennedy, do you want to help us substitute that in? No. Which one do you want to substitute it into? This one or this one? Or doesn't matter?
Oh my god.
Doesn't matter. They're congruent.
I don't care.
Okay. I'll pick this one for you since this one has a smaller number, 4.
Okay.
Okay? So it'd be what?
4 parentheses 6 parentheses plus 7.
Very good. We take 6 and we put it in place of x. That's what substitute means. We put it in place of it. It's a substitute for it. We put it in place for it. Yes, Randall.
Wait, why did you put A as congruent? Why did you do the circle thing?
This arc,
Yeah.
because these 3 angles are congruent. Alicia said at the beginning, since it's equilateral, we know all the sides are congruent and we know all the angles are congruent. So I went ahead and marked it because she said it. We aren't going to use the information on this problem, but she said it. I went ahead and marked it because it is true. So now, how would we go about solving this here? Kylie, what would you do? So if this side is 31, what's this side?
31.
And what's this side? 31 is equilateral. So the length of each side is 31, and in this case, centimeters.
Oh, CM.
Very good. So in this case, it's 31 centimeters.
Will we put that on the sides of the triangle with 31 too?
Good. If you also just put 31 centimeters once here, since it's an equilateral triangle, that would suffice as well, since they all have the same length. Questions on that? Okay. So let's look at B. Find the measure of angle T, okay? I want you guys to work on this one on your own. I want you first to try it on your own. Okay, I want you to try it on your own. Think about what you might know. First, think about what kind of triangle it is and what we know about those kinds of triangles.
These are inside. What kind of triangle is this?
So I like what you're doing. That's a good idea. The only thing is you know what this angle is number-wise. So I don't know how to find interval x. That's a good idea. So if we knew the number, that'd be great. Okay, what kind of triangle is this?
I did it.
Said it's like 30 triangle. So that's here right then. What's the base angle here? So the side.
I knew you.
No.
Yo, hold. I know, hold the book. Why? Because it's straight from your shirt. It's very orange. It's an old man question. Yeah. Have you been to some Nelson? I don't know if you.
I want to do that.
I have a 57. They're equal. All sides. Oh, just
Where?
Yeah, equal 180.
Oh,
No. Oh, they are? So,
you're messed up.
Also, can we look at the second one? All right. New count.
So if you 3x times it by 2x.
As you can hear,
Oh, plus x.
did you actually get it?
Oh, just like this, right? Why not set that? Oh, I got it now.
Are you grounded?
Well, here, this is that.
From people.
E to B?
Wait. Even.
What? You can say random.
Everyone. That's all there is.
Not be off.
I think, because I don't know. I get my phone bill in my credit. That's what they normally do. If I have two seats, if I have more than two.
My mom was like,
Please get it so I can see it. And my dad, he was like,
I fix problems, I don't fix lives. Not quite there yet. I'm not,
Great.
no, it's actually, yeah, I think it's, I'll do it.
103. Yeah, I know.
I've been- Oh, they make a lot of money.
Narrow surgeon.
They make a lot of money.
That's what I would have for that. Not a neurosurgeon.
No, I want to be a surgeon.
Yeah.
I want to orthopedic.
I'm like a doctor.
But I, honestly, honestly, I'm gonna go to school and be like, I'm done.
Well, the registered nurse that I talked to, someone doesn't have more than me. I can't be a nurse if I do shots.
I know, but I'll be in so much debt. Just become a nurse. No. You know what they do?
I was just leaving.
I don't want to do that.
Because he wouldn't be in the other shop.
Not all the time. You also do the, you have to also do the terrible stuff.
Yeah, tests. I get tests on my watch. Like, when I had that like spot thing. The vaccine is blood times.
I know, but I'll just pick up the couple of times. See, that's terrible. I'm not doing that. That's terrible.
I loved it.
What'd you do?
The two ladies were sweethearts that I worked with. It's naturally healthy kids, like a pediatrician clinic all the way out in Omaha.
I feel
You know, vaccine.
The pediatrician had a lot of meetings.
I'm just different.
that's what I was last night.
I've tried that.
Feels weird.
I can't write down.
Exactly.
Alright, class, we're gonna talk about this one together real quick. Okay, class, we're gonna talk about this one together real quick.
I'll let you it.
Attention to back up here.
Call me.
Okay, Gracie, what are you gonna do?
X. You put an X like in the angle of X
Okay, how do we know that's X?
because there's nothing else there.
Okay, there's nothing else there, so we just randomly decided X goes there. Bless you, bless you, raise down now.
They're congruent.
This angle and this angle, voices off everybody. This angle and this angle are congruent because they're base angles in a nice isosceles triangle, okay? So they're congruent, meaning they're the
I'm
same
into
measure.
all of it.
Okay, Gracie, keep going.
3x plus x plus x is 5x.
Okay, well, 3x plus x plus x, what do all three of these angles add up to be? 180,
180.
because all the interior angles of a triangle add up to be 180.
Girl.
So, Gracie, you said 3x plus x plus x is 5x because they're like terms. And if we don't see anything in front of an x, it's like a 1x. So 3 plus 1 plus 1 is 5.
Divide by 5, divide by 5, you get 30.
and we'll divide by 5 on both sides. X is equal to 36. So now we need to find measure of angle T. Calm down a second, Gracie. Okay. So we need to find measure of angle T. So Gracie, what would you do to find measure of angle T now that we know X?
180 minus 36. Plug it out.
Plug it
That's what
in.
I meant.
Okay, you plug it in into 3x. Brody, make sure you're paying attention to this part. This is the part we missed off. You were about to talk. Okay, so 3 times 36. And what does that work out to be?
108.
108 degrees. So we will say that the measure of angle T is equal to 108 degrees. Questions on that one, class? Okay. All the others are very similar to that, or simple steps from that. So we're actually going to skip the rest of the examples.
Okay, what's the next one? Please.
Yes, that's an isosceles triangle.
Nice. Well, schedule report.
At least that one.
Sundays were closed. How about Friday at
It popped up in my memory the other day. It's like, what? I remember when we were in school, I was making my arm and you went,
Do you want this?
all the way down to your toes.
Hey class, this is information you might want.
I'm gonna take you guys out.
This is information you might want. We will not be doing certain numbers. We don't do number 8, 11, 12, or 14.
8
You can cross those out. You're not going to be doing number 8, number 11, number 12, or number 14. So you can cross those out. I knew you would complain about it.
Definitely won't.
I will. Bet.
I'm gonna test on Friday. Quiz.
Yes, I did.
I'm assuming that you really want it to be X instead of S.
Oh,
equals-
thank you.
No, it's fine.
Okay. Hey everybody, real quick. If I can get your attention up to the board, please and thank you. Okay, if we look at this one, on number 3, everybody look at number 3 real quick, please. So this says S equals. That should really be an X. That's a typo.
It's fine.
So heads up, that is an X equals, not an S equals, okay? So X, not S. Yes, Faith? Oh, Faith is asking about number 2, why there's an arc with a line. That's just what sometimes textbooks or people will do. Instead of drawing 2 circles or one arc or 2 arcs, they'll draw an arc with a line or an arc with 2 lines or an arc with 3 lines instead of number of arcs. So it's still, this angle is congruent to this angle, is still what it means. It's basically the same thing as our arc.
Listen up, kids.
These 2 angles are congruent, and we need to find one of the angles.